So the next session we're going to do is talking about Store Connect and transaction service. So kind of the agenda is a quick functional overview of what actually those two components do. Then we'll take a look at how you actually configure Store Connect and the transaction service. And then we kind of take a look at how those components actually work and how they're implemented. And then as a final thing, we're going to take a look at some of the monitoring, logging functionality that comes with it, and that kind of can help you in terms of troubleshooting if there are any issues. So I think it has been mentioned a couple of times in terms of from the basic functionality, what it actually does. Store Connect, the default configuration is you have one or more instances running at the headquarters. Here we're going to show it as like on its own dedicated communication server, and there probably will also be an instance running at the store. So Store Connect is kind of used to do batch mode, large volume data transfers. So any kind of master data updates, new price changes, new items, new customers, etc., are being pushed out. They can be scheduled so that they run periodically. Certain things you want to send every few minutes, other things you want to send like in the middle of the night. So that can be all scheduled to the requirements. Then the transaction service is you kind of saw what Jeff demoed earlier. This is really kind of real-time access into AX. I'll kind of show later on some of the functionalities that are required there. The same thing, it's transaction service itself. The service is running at headquarters. The same thing, you can have one or multiple instances running there on this communication server that we're showing here. And then the POS application has sort of like a client that will actually interface and initiate the calls going out there. So that is really kind of designed for kind of ad hoc querying, looking up data, and then, creating the sales orders. The other thing I kind of show there is the offline database. So this is really outside of the Store Connect. Store Connect will no longer talk to the database on the individual terminals. It will only pick up or deliver data to the store database. So from a configuration standpoint for Store Connect, this is the next thing we're going to look at it. There's sort of three key things that you need to be aware of what needs to be configured. Those are the connection profiles. So if you think about it, the data transfer needs two endpoints. One of them is the AOS, or the data in AX. And for that, you configure the AOS profile. You specify, which AOS server you want to use to where it is, how it's configured, and then that's one endpoint. The other endpoint is then a store database or multiple store databases. So for each database, you will need a database profile. And there as well, you kind of configure, the server, the database name. It's kind of like a connection string. And then on top of that, you have, as I showed earlier, you have multiple instances of Store Connect actually running off the service. So you need a profile for each instance as well. And I'm kind of showing here the upload options. We'll kind of talk a little bit more about that later, but that allows you to basically have Store Connect upload status messages into AX so you can actually monitor what is going on while you're sending the data. And the other key concept in the configuration here is the distribution location. So the distribution location is really a link between the business entity of the store and the connection profile of the physical connection string to the database. So in that way, we're kind of linking this up. So if you create a new store, we automatically generate a distribution location that is linked to that store. And then I guess it's probably easier if we switch to this graphic to kind of explain on how this is configured. So as I mentioned, if you have like the store database. You create a database profile for this. You configure, whatever you need to get to that database, and then you have the distribution location. So that database profile is associated with this distribution location. And then from the distribution location, we go to the actual business entity of the store. So if you assign whatever a assortment to a store, when we actually send it down, we're going from the store, we're looking up the distribution location. From there, we then, through the database profile, we figure out where the database is. And then the other thing that's associated to this database profile is the Store Connect profile for the Store Connect. This is running out in the store. So with this, we actually know how to send it there. We know it has to go to the Store Connect at the store. We have the database that it's going into. And then if you send this assortment out there, we know exactly where to send this. Then the similar thing basically works for the AOS side. You set up an AOS profile for your AX instance. If you have multiple Store Connects running, to kind of spread out the load, you can basically then configure multiple profiles and, for example, point them to different instances of the AOS. And then the same thing, this AOS profile has this Store Connect profile attached to. So if you then basically send out the data, the HQ Store Connect will actually execute and extract the data, forward the data package to the Store Connect at the store, and based on the database profile, we are writing it into the listed database. So this is kind of sort of the sequence, probably how you would configure a new location. So you have a new Store Connect instance, you create a new profile, you set it up. The key things are here the service name and the server name. The service name is basically the name that the Store Connect instance is configured for. The server name is the physical PC that it's running on. By default, it's the same, so it's in my screenshot, it's the same, but it can be different things. So it's kind of a little confusing to just make sure that the server name is correct and then the service name for that as well. So if you have multiple instances running on the same box, you could have like Store Connect 1, 2, and 3, but they're all running on the same physical PC. The other thing is then the port number. So since basically Store Connect is using TCP/IP socket connections, they all listen on a socket. So by default, the port number is 16750. This can be then if you have multiple instances configured on one box, so obviously you would have to have different ports associated to that as well. And then the other two checkboxes that follow there about the disable IPsec is kind of really in terms of how you want to manage or how you accommodate some of the network configuration there. So by default, we are recommending that you use IPsec as securing the communications channel and also authenticating the communications channel. So if there's already a VPN or some other way of securing this channel in place, you can actually disable this. And then the prefer IPv6 is, there were some issues that we actually kind of come in as a bug fix, is that if by default, if you're in a mixed environment where you have both IPv6 and IPv4, we needed to specify which preferred port the service was listening on. So you can specify now if you have at HQ already IPv6 and IPv4 still deployed, but the store has 4, you can specify which one this instance is listening on. And then the last two on there is the transaction service profile and the connection upload profile. This is, as I mentioned, if you want to upload some of the status messages from Store Connect into AX, this is what you configure that. We're actually using the transaction service to bringing those messages into AX. And then the upload options, you can kind of have some configuration options in terms of what you want to upload and how frequently. Then the next thing that needs to be configured is the database profile. As I said, that is for the store database. You specify a name for it. You know, this is very creatively named sample profile, but you know, probably you would use the store name or however you want to identify that database out there. And then there's a version number, so you can specify which version of SQL is running out there. The server name is then basically the PC name / instance name of the SQL server that is, or SQL Express, whatever is running out there. And then obviously the database name. And then there's an option that you can actually encrypt the database connection, that when Store Connect talks to this store database, this connection can be encrypted if this checkbox is checked. And then the last parameter there is the actual Store Connect that is running out of in the store, and that will be essentially managing any data transfers to and from this database. And then here I'm showing that this database profile that we just created was assigned to store 1. So that is then, as I said, the connection from the physical database through the distribution location to the business entity called store 1. So this is the Retail Store Connect profile that we have set up. Did I press the wrong button here? No, I'm showing the same steps for AOS. So I don't go through this. This is basically the same configuration on the AX side. You use the Store Connect profile. Then you create the AOS profile. Same thing. You give it a name that explains what it is, where it's running, or things like that. Then the server name is basically where is the AOS running. And then the instance name of the AOS instance. And then the TCP IP port that's listed there is the port that the AOS is listening on, which by default is 2712. And then also here you select the Retail Store Connect instance that is basically talking to this AOS. For the transaction service, the configuration is slightly different. It's a Windows service as well, and there is a transaction service profile that is assigned to the POS terminal, and that basically tells the POS terminal which transaction service it needs to talk to. That's kind of configured. I'll show you then what the options are as well. And then the other thing that you need to configure is the retail transaction service.exe.config. That's basically a .NET kind of config file where you then also specify like the AOS that this transaction service is talking to. So this is the transaction service profile that is associated to a POS terminal. So you can give it a name, and then you specify, excuse me, you specify the server name. This is where the transaction service is running, and then you specify the port that this transaction service is listening on. And then it is also required that you enter a passphrase. This passphrase is basically used as part of the authentication method between the POS and the transaction service. So if both kind of the transaction service and the POS have a matching passphrase, they can actually then decrypt and encrypt the data that is going across the channel. And then this is the transaction service config file. I kind of highlighted the two key areas. First one is basically the port that it's listening on. And then the second one is the AOS that it's talking to. It's kind of the format of the AOS instance name at the server name that the AOS is running on, and then colon the port number that this AOS instance is listening on. So with that, I'll do a quick demo. So if I'm creating a new store, say store 100, we kind of pick any warehouse since we're actually not planning on using it. And the same for the other options. Uh-oh. Let's see if that is unique. So we've got some problems here in terms of how stores are created. Interesting. Let's see if it actually created the distribution location. This is actually what I'm interested in. It kind of partially created it, so there must be some issues with the number sequences, how they are set up, because it seems to be conflicting with what I'm trying to create here. But hopefully for this example, to just showing you how this can get configured, it's probably okay. It probably won't be usable, but that's, I think, fine. We just want to show how to configure it. So here is, as I said, the transaction, or the Retail Store Connect profile. And this is basically the configuration that you're going to see on your VM. You got the service name here, which is by default the server name that it's running on. And then the port number it's listening on. Here we're actually saying we want to use IPv6, and we're also okay with running on IPv4. And then the timeout is actually a timeout that is used for the SQL connection. So by default, we are specifying 0. There's no timeout. But if there's some issues where potentially Store Connect could hang, you can specify a timeout that will then basically terminate the SQL connection, and it will continue. And then here you got the retail transaction service profile that we're using to upload the status messages and then the upload options. If we then go in here and let's say we're pretending that this store actually was created, we create a new database profile. We're running SQL Server 2008 R2. The server name, let's say it's also store 100, and the database name is also store 100. I want to encrypt the database connection, and then I assign the one Store Connect. I only have one instance running here. Assign it to that, and then the next thing I would do is go to this distribution location for this store 100 that I just created, and I'm actually assigning then this database profile to it. Okay, I guess since it didn't get fully created, let's just fake it here and pick another store, and hopefully we can. That's too bad. And then the same thing you would do here for the AOS profile. So if you had an additional AOS instance running here, I could create a new profile here. The other reason why you would create multiples is, even if you have just one AOS running, is if you have multiple Store Connect instances running. This is sort of more of a scalability option. So you would install a new instance of Store Connect in the same box on a different box, and then basically have a new profile. It can point to the same AOS, but it gives you an option to scale out. So you got the name here, server name of the VM that we're running on here, the instance name of the AOS, the port number, and then the Store Connect instance that is running here as well. Then the other thing that's, I think, covered in my next slide, but I'll do it here anyways, is then the distribution location list. So that newly created location, which unfortunately didn't create, you would then have to add to this distribution location list. That is basically, you can build distribution locations based on time schedules, locations, however you want to set it up. It's basically a group of stores that you want to send data to all at once. And then the other thing I want to quickly show is actually the Store Connect configuration utility. So here is, if you wanted to create a new instance here, it obviously tells me it's already here. Let's call it B. We create a new one, and then it actually prompts you to create the database. I hope I remember what that is. And then the username, say Kotoso, logged in as MAH, and then the password for that service. So the key thing here for this service account that I'm specifying here, since Store Connect will be talking to AX with this account context, this actually has to be on the HQ side. It has to be a domain user, and it has to be an AX user that has read and write privileges to all the data that needs to be transferred. So we created this new service. It will have created now, it's the message database behind the scenes. And since we're having the same port here, we can specify we're going to listen on port 751. And then basically that would be it, and you can start it, and it should be available for use. So I probably mistyped the password. So that is kind of configuring a new Store Connect instance, and then you would, for example, now go for the same motion, creating a Store Connect profile, and then associating it for use. So with that, we're going to take a look at how actually Store Connect and the transaction service kind of, oops, sorry. How they actually work. So when we talk about Store Connect, there are actually sort of two parts to it. One is this the scheduler, which is actually in AX. And so it's obviously written in X++ code. And it has kind of two core, or three actually, core functionalities. One is all the configuration, that kind of what we are talked about, or what I showed you here in terms of how you set up the communications endpoints. The other thing is it also does all the change tracking for, like, we talk about the later in bit how that works in terms of like what data needs to be sent where. If something changes, it figures out where to send it. All this, and the third part is where actually the name comes from. It's kind of initiates, schedules the data transfer. So every data transfer is initiated from within AX. So even if you're uploading, for example, POS transactions from the store, the request has to actually come from AX to say, I need those transactions, and then they get uploaded. Then the Store Connect service itself, it is a Windows service, and as I mentioned, the username it runs under has to be an AX user with access to AX. So what the Store Connect actually does, as a service, it receives a request from AX, either an insert or an extraction request, and then basically executes it based on the direction of the data flow. It's either we send down to the store and says, send up the POS transaction, they get then uploaded to AX and inserted there, or vice versa. It will extract some data from AX and then send it down to POS and insert it there. So it is really just sort of a data transfer mechanism. There's not much logic in there. It just knows what to send where based on the information that it gets actually from the scheduler in AX. So the components of what it kind of looks like in terms of a very simple configuration. Here's kind of what it probably would look like on the VM where we only have one instance of Store Connect running. So you have AX, and then as part of AX, you get the scheduler code. And then the other thing that's kind of on the side here, this is the Transautom client. That is actually a DLL that we're using from the X++ code to initiate the communication with Store Connect. So that actually opens the socket and talks to the Store Connect instance out there, and that receives then the request. In return, when Store Connect actually talks to AX, there's a specific AX adapter that we wrote. This adapter uses PC.NET. So if wherever you install Store Connect, you also have to have an instance of PC.NET installed. And then on the other side, on the store-facing side, there's a SQL adapter that then talks directly to the SQL database at the store. So this kind of will kind of show how the actual flow is. If you have it set up, you have now two Store Connects, one at HQ, the other one at the store. So the first thing that happens is there's a request generated in AX that is being sent out to the Store Connect instance at the headquarters. This kind of request is then actually stored in a working folder. So there are sort of two things to a Store Connect. One is the message database that it's using. In there, it kind of keeps status about the actual transfer of the data. And then there's a working folder. In this working folder, we're basically storing the first thing, as I'm showing here, the request went out there. Think of it that is kind of a pseudo query of all the data that needs to be transferred at this time. So this request has been stored in the working folder. Then the next thing that is happening, there will be an entry generated in this message database. Basically, it says, hey, I received this request. Then the Store Connect will turn around and basically grab this request, execute the query, retrieve that actual payload, the data that is to being sent, which then also will go into this message folder. And obviously, we'll create another update in this message database saying, yes, we now extracted the data. From there, it actually picks up that data package, opens a socket connection to Store Connect in the store or the multiple destinations that it goes to, and it will send that request out to the destinations. And at the other end, I didn't quite show it, but it does the same thing. It will put that message into or the data package into this working folder, create an update in the message database, turn around, pick up that data file, insert it into the store database, update the message status, etc. And then, for example, if we have configured that we want to upload the status messages as well from Store Connect into AX, it will turn around and upload that status into AX so we can actually take a look at it from WinAX, what just happened there. So this is a more detailed view in terms of the sequence for both data downloads and data uploads. So in kind of both scenarios, you have the first thing, you have the request going out from AX. If it's a data download, we're talking first to the Store Connect at HQ, which then here it turns around, executes this query, gets the data, and then sends it down to just the Store Connect in the store. From there, it actually goes into the store database. Now, the data uploads work slightly different. This is this scenario here where actually AX will directly connect this or contact the Store Connect at the store and send the request down there. And then at that point, that instance will query the data extracted from the POS database and then upload it to the Store Connect at the headquarters, and from there we're turning around and inserting it into AX. So there are a couple of things I want to kind of highlight in terms of some of the things we're doing here. For example, on the insert of data into AX, we're actually using a new, at least in AX 2012, we're using the new capabilities that were introduced in X++ of using actual SQL temp tables. So basically, the Store Connect writes all the data into this temp table. So there's actually, SQL will pick up the file and physically import it. So that one of the reasons we did this is obviously the performance. It's much better, much faster than the previous record-per-record insert into the data set in X++. So and then when, from those temp tables, we're actually copying them into the actual POS or the actual retail transaction tables, whatever, 16 different tables that we have. On the data download, we are kind of doing a similar thing at the store side, where we're also using a SQL bulk copy to kind of enhance the performance when we do a bulk insert at the store side. So with that, I guess we're kind of talking a little bit about some of the scalability options that are available in terms of how you could configure Store Connect. So this is kind of showing a very kind of simple setup. You have got one Store Connect at the HQ and then one Store Connect for each store that is out there. Then there are additional options in terms of how you would scale out the performance. One of them is obviously just installing a new Store Connect at the headquarters, and then basically I can show you that later. Based on the distribution schedule, you assign different stores to different distribution lists, and then this distribution list has a AOS profile associated with. And that means whatever for store 1 through 100, they're going for Store Connect 1, store 100 to 200 to Store Connect 2, etc., etc. So you can kind of split up the load that way so you can actually enhance the performance. The other option is you could, for example, just have a dedicated Store Connect instance that is only accepting data uploads from point of sale. So there's one other thing I kind of want to point out here in terms of, since from the scheduler we can send out hundreds of requests to upload POS data all at once. If they all come in kind of at the same time, Store Connect is able to accept the multiple simultaneous connections to actually receive all that data. Will all get kind of buffered into this working folder. But when it actually inserts the data into AX, that is actually single-threaded. So this is going to be sequential. So there might be some delay based on, if everything comes in at the same time, you might see some delay in how that gets applied. So there's this option, as I mentioned, just configure the same thing, configure multiple instances for receiving data, and then that will allow you to scale out as well. And then an additional option is this kind of forwarder mode. So what this does is you can install an instance of Store Connect, and there's a kind of like a drop down there that says, I think, second stage processor or something like that. If you configure it that way, that means this Store Connect has only one functionality, and that is essentially picking up the data that was generated from its kind of partner here. This instance will receive the request from AX, will extract the data package, and then stop. And then the second this forwarder instance will pick up and basically forward send out the data to the actual stores. So this is kind of one option where, for example, you send a lot of data to, or the same data to a lot of stores. It means the extraction is pretty fast, but the actual distribution of sending that data package out there, which is exactly the same, but it goes out, for example, over a kind of slow communications line, that's actually might be a bottleneck. So to avoid that this kind of, the first instance of the Store Connect kind of gets tied up with just sending stuff out and basically would be not able to receive other requests, for example, from incoming data packages, uploads, you could sort of offload this forwarding task to this instance of Store Connect. Then there are a few other sort of core concepts that I kind of want to touch on. Is the scheduler subjob. This is then the subjob mapping is really a definition of what fields of what table, of one table go to the destination. So in most scenarios, the store database schema is sort of a subset of the AX schema. So here you can specify for whatever the invent table, let's say I only need those 5 fields that I care about, and then you specify those fields, and they will be then sent to the store. Then for the scheduler job, this is then really a kind of grouping of all the sub-jobs, or all the tables, if you will, that should be transferred all at once. So if you want to send all the items down there, then here are whatever the 16 tables that you need for an item to be functional in POS, and you want to send those all at once. So what that really means is a scheduler job itself will execute within the context of a SQL transaction. So for example, if you have those 16 tables that go down there and the 5th one fails, we're going to roll back all the previous stuff. So you will not end up with some partial inserted data that is not usable. And then the distribution list, I kind of talked a little bit about there, is just you kind of define a collection of stores that you want to then use for the data transfer. So you can, based on schedule, based on location, based on just load balancing or other options that you want to consider, you just group some stores, can then set them up and schedule them to send out. And then there are 3 different job types. The N job basically sends all the data within the AX table. So this is really, think of it a select all, no query, no criteria on it, we just dump the table out there. The one thing I want to point out here is since the scheduler configuration is global and they can run for stores that are in different legal entities, it will actually respect the data area ID. So if whatever it's, let's say the invent table, which still has the data area ID on the invent table, it will only grab the records for the data area ID that the store belongs to, not everything in the actual table. Then on the receiving end, this is something to be also aware of. It actually will perform a delete. All the records in the store database will be deleted before we do that insert. So that might be, in some scenarios, a good thing when you just want to get to a certain state where you just want to wipe out the store database and then insert those new records all at once. The A job is then kind of very different, and that's kind of our recommendation on how data should be sent out. This is really based on actions. I guess that's where the name comes from. And an action is really, there was something performed, something was changed in AX. We're keeping track of that. And then we figure out where it needs to be sent. So it's not like this data dump. It's just, I have 2 changes. I know where to send them, and they go out there. So it's much more efficient in terms of the data volume, and also you really know that you don't have, you kind of have to keep track of when you run the job. It's just, you run it every half hour or so. You make a change, you can be assured that the data goes where it needs to belong. And then the P job is sort of the reverse thing. We're uploading the POS transactions into AX. And then kind of to illustrate this a little bit, as I said, you have the scheduler job. That's the definition on the table level. Then you group them into a scheduler job. This is kind of your entities, customers, items, etc., all the tables that are related to that. Then you create the distribution location list. This is the targets, the stores that you want to send it to. You combine those 2 into a distribution schedule. So at this point, you could then manually execute the schedule, but most likely you want to assign a batch job to this distribution schedule and then basically say run it every hour, run it at 10 o'clock at night, or whatever the requirements are. So this then the kind of few screenshots of how this is configured. You have the scheduler job name, sort of the entity, as I mentioned, for currency here. And then you've got all these sub-jobs, all the kind of tables that are related to currency and that are being sent down. Then this is the distribution location list. You define whatever list you have at the stores, the locations that you want to send to, and then be included all grouped together. And then this is the distribution schedule. By default, we basically have a distribution, sorry, wrong button. We have a distribution schedule for every one of the scheduler jobs. So it's kind of a little confusing because this form pretty much looks the same as the previous one for the scheduler job, but it has a different functionality. So you have then here the distribution list where you want to send it, and I guess I can't get there, I'll do it over here. And then you have the scheduler job that you want to actually run there. So for example, the sample I'm showing here, I just created a distribution schedule that runs all the A jobs. So if I just don't care at what time or whatever they're being sent, I'm saying any changes will be sent every hour. I create one schedule, I add all the scheduler jobs to it, create one batch job, set the recurrence to an hour, and every hour I'm sending all the changes that I made in EX down to the stores, or the stores that are listed for this schedule there, to be more precise. So the next thing is we're going to take a summit. We got some issues. My mic is situated the wrong way. Okay, is this better? Okay. So we're going to take a quick look at how A jobs run, because they kind of have somewhat different functionality. So what I'm showing here is, let's say you're making a change to an entity in AX. We're doing then the kind of change tracking. We're logging this, writing it into a table that's called the retail pre-actions. And then there's a process that is run also in a batch job or whenever you will, that will look at the table distribution. And we'll take a look at that next, what that actually means. But basically, the table distribution defines on what data will be sent where. This is kind of sort of a hierarchy that links it back to a location and has all the links. And basically, based on that, we kind of can build a query saying, because of this change, we need to send data out of those 10 tables to this location. With that result is then written into the retail actions table, retail con actions table. And whenever then the scheduler job executes, it will look for any changes or any actions that are listed in there for this particular entity or for this particular table, process them, and then send them out to the store. So for the pre-actions, which is really just kind of a record that something has changed in AX. So how we are doing it is basically we are overriding the create, insert, and delete methods of every table record that we're interested in for retail. And then on top of that, you have the option that even if the code is there, you can specify that in this filter on action creation, if you're really actually interested in that table and tracking the changes for that. So, and then in addition to that, you can also specify which fields you want to track. So for example, I'm showing here the invent table, which I think by default has 100 plus fields in there. But the POS really just cares about 3 of them that we are sending down. So if something else changes, that if you, let's say, change whatever, something related to purchasing that POS doesn't care about, we don't want to have a change record for that and actually send the record down that it hasn't really changed from the point of sale perspective. So this is the option that you can really tune what you want to send based on this configuration. What tables, what fields you want to monitor. If anything like this changes, we're creating a record and then we're sending it down. And then this is just a quick screenshot of what is actually in that pre-action table. I don't know if it's how readable it is, but it basically is just a record of, tells you which table was changed, the action it was, the key of the record within the table that has changed, and obviously the housekeeping stuff of time, date, time, who's done it, etc. And then a key part of the A job is the table distribution. So this is kind of a setup that really defines on where the data is sent. So there are three sort of distribution types that you can set up. One is the all distribution locations. That means if there's one change, it goes everywhere to every store. We don't care if there's any relationship to it. We're just sending it to all the stores. Then the second option is by distribution groups. In that scenario, we always need some link back to a store. So this is, for example, for an assortment. We can figure out the assortment is assigned to whatever store group. Here are the stores. And then there's a distribution location that is associated with it, and all the way down which record is associated to that assortment. And based on that, we know that there's a relationship between these stores and X number of items that have changed, and we're sending them down. And then the same as parent distribution is then, as you build this hierarchy, and I'll show you that later, is basically saying this table is sent along with its parent. So whatever you have, like the invent table, and the child is like, for example, the invent dim. It just goes along with the invent table record. And then there are three other interesting concepts, and this the link down settings. And this means basically if there is a child table that is associated with this, so you have whatever is at the invent table and then all the other tables that are below that, this link down option specifies if you're saying link down on insert, that means if you created a new record in the invent table, anything below that that is listed will also be sent down. Although there may not be a record that was created at this time, because you may have linked just an existing record to it. So like whatever, a sales tax group or something like that came out of a drop-down. There's nothing else changed to the child table. But since it is required to be sent along with this parent record, otherwise it would be an incomplete record, you set this option to link down on insert. Then a similar thing is then for the update. So if you're changing something in the item, do we need to send all the other records, all the related records there? Probably not. Because nothing has really changed except maybe the item's description. We don't need to send all the related data down there. So you could, for example, just say, well, we uncheck this. We don't need all the related records. We just send the actual change that actually happened. And then for link down on delete, that's, yeah, was there a delete record for this table? Are all the children being deleted as well or not? So this is something you kind of have to be careful in how to configure it, because especially if it is a linked table that might be used by some of the other records, if you check this as a delete, it will wipe that out, and you may have an incomplete record for some of the other dependencies that still exist. So this is kind of what the table distribution looks like in a tree view. As I said, the key thing is here. That is the distribution location, which is basically a store. So everything below there is somehow linked to a store, so we can identify where this record needs to be sent. And then over here, then you have the distribution. How do you distribute it? In terms of same as parent, then the link down options, etc. And then down here, we, for example, the price discount group, we just send everywhere because there is no relationship between a store. Because if I assign a price group to a customer, there's absolutely no link to the store. So in this scenario, we just configure it, it will be sent everywhere. You create a new price group, every store will know about it. And then this is kind of the link between those tables. So if you have like the parent table and the child table there, So in this scenario, we have showing the link between the retail store and the retail's con distribution location. So this is really kind of the join between those tables, or the foreign key relationship. How are those tables related, and how do we, when we actually making a change in the parent record, how do we figure out how many of the child records are sent? Is it just a one-to-one? Is it one-to-many, etc.? So that is kind of the link between those two records. So there's two tables in that record, the record in the table, I'm sorry. And then basically we're building a query that then executes it and says, we're starting up there, here's the relationship from whatever, the store number to the assortment number to the item table to the invent table to the whatever else goes along with it. There's always a link there. We're executing this query. We're retrieving all that data, putting it in one package, sending it down to the store and inserting it. And this is then a quick look at what the actions look like. It pretty much looks the same as the pre-actions, as just a record in there. What is the table? What happened? An insert, an update, etc. The reference ID or key, in some cases, it is still there. In some cases, it's not, because we're actually storing a serialized query in this table. So they're based on certain criteria in our code. We actually just either storing the record and saying, here's the record that you need to send, or if it's a larger data package, we're just dynamically building a query that we're saving and then sending to Store Connect and saying, just execute this query and you get the data. And that is then a quick demo on what we kind of talked about here. So if we start with the scheduler subjob as sort of the base building block. So this is kind of, it really doesn't matter which table we're picking, but the retail barcode mask table. And from a design perspective, the from design is basically where's the source and where do we read the definition, like the schema, the field mappings from. And by the same token, the to, like where do we read it from. So here we're using the Seattle store as sort of like the template for all of them. But you could have multiple, if you have different schemas in different stores, you just select a different one. And the drop-downs that I'll show you later in terms of how you map the fields, etc., would be different. And then a couple other things in terms of like the data area ID. So for some tables where you still have the data area ID or where actually the store cares or doesn't care about the data area ID, you can actually specify if you want to send it down and then like specify the field that it is. By default, it would always be the data area ID because that's the field name in the AX table. Then over here, you define the method of replication. So that is what we mentioned earlier. It's either normal or by action. Normal also applies to like a P job. And then the field transfer type is an include list. That means we're specifying the fields for this table explicitly in terms of what we want. And you could also do an exclude list where you basically say send everything but those two fields. And then here is essentially the actions that are being performed. For an end job, you want to do a delete first because otherwise the insert will fail. So you can set up here, it's delete first, then insert, and then you have an option to actually enable it and disable it. I don't know where that would be coming in handy because there's still another option, the scheduler job. When you say, I don't want to send those two tables this time around, you could disable it, but you can do it somewhere else. And for the P job, you would select this. That would be then a pull job. That means I want to actually read data out of the store database. And then here's basically the field list. So you can map from the from field, in this scenario it's AX, to the to field in the store. In most scenarios, since basically the POS database is a subset of the AX database, it's going to be the same tables, the same field names, so there shouldn't be anything really necessary to change. It should be the same data types. And then there's some options in terms of some conversion types if you want to do something. So you could, if you need to do some transformation based on, if you have some customizations where you want to need different data in the store than what you have in AX, there's some options here in terms of putting a constant in there. For example, this record doesn't exist in AX, but POS terminal would require it, so you could specify this, and then insert some date times and things like that you could then specify here as well. Another thing here is the from table filter. This is almost like you want to restrict what you want to send. So this could be, for example, if you have for the first time you want to send all the customers down to the store and you really have tens of millions of records in there, which probably would put a strain on the system if you send all of them at the same time. So here you actually could create a query on this table and say, I only want to select everything with a record ID or whatever, customer ID or whatever it is, larger than whatever, or smaller than, etc., and kind of specify a query of what you want to send. It's probably not something that will be used in everyday scenarios, but it's kind of sort of workaround if you're kind of concerned about the volume of data that is being sent all at once. Then if you're moving one level up to the scheduler job, so then here you have then the sort of the roll-up of all the sub-jobs that you created. That's the kind of table by table. And then this is the so the grouping for currencies. You need all this, whatever the currency, the exchange rates, etc. Excuse me. I guess my voice is going. One other thing I kind of want to point out here is for the POS transactions. As I mentioned, we're using temp tables. So if you're modifying some of the tables and add or remove a field or create a new table and include it in this P job, the upload job, you also need to create the temp tables. So you just click on this. This will create then the temp tables in the AOT, and then basically we can use the same functionality as the ones we are sending by default. And then the next thing we're going to look at is the distribution schedule. So by default, we have really, for every scheduler job, we also have a distribution schedule. But if you want to create a new one, and as I said, whatever it is, you want to have items and prices, then you select the AOS profile that you want to use for this. So if you want to, as I said, load balance, this is here, you would do this. You get the same schedule for different store groups. And then here in the distribution location list, you then add the locations. Here's the default include list, but if you want to split it up, you can have the multiples that you add here or just the one per schedule. And then down here, you associate the actual scheduler job that you want. So we want the discounts, and we want the product and prices. And then basically you could run it here directly, and it will now execute those two scheduler jobs. We'll send it to the stores that you selected there and send it out. But most likely you probably want to go here and then create a batch job, select the recurrence, and then set it up to whatever, run every hour or at a given date, time, etc., however you want to run this. Then the next thing I want to kind of take a look at is the filter on action creation. As I mentioned earlier, this is really just you add the tables that you want to track changes for. So this is kind of the default settings that we're shipping. If you add a new table that you want to also track changes for, as I mentioned, you have to add the change tracking codes that we added to the insert, update, and delete methods. Add it to this list here as well. And then over here you specify the fields that you actually are interested in when they're changing. And then we're going to take a look at the table distribution. So by default, that's kind of a flat list, but we also can display it as a tree view, which kind of makes it easier to actually figure out what's going on. So if we're looking, for example, at the assortment, so we're building up this whole hierarchy all the way down to all the tables that are related to a product. So the whole list that is basically tracked for an assortment. And if we're following this down, as I said, this is the distribution location, which is then linked to the actual store. And then from there, we have the retail channel. And then the retail assortment exploded. That is the kind of flattened list that Jeff, I think, talked about yesterday in terms of how we figure out which items go where. And we kind of run this on a periodic time schedule. And then all the related things from the invent table to the EcoRes product, anything that is kind of related to a product is set up in this hierarchy. And basically that means if anything along this line changes, we always can kind of from the, let's say the retail special category member has changed, we have a record that this has changed. So we are walking up this whole tree through these foreign key relationships and then saying, oh, by the way, it affects those 3 stores, and then we can compute where to send this data. And then the key thing is here the table links, as I mentioned, which basically determines the link, foreign key, join, whatever you want to call it. That's the association between those two tables. So there could be multiple links per table pair. So if there, if there's, for example, a link on whatever from a customer to the customer group, price group, there's the association between the price group ID, but then also since there are multiple types of price groups, you would specify that it is of type X. So we're only picking up the specific customer price group, but not, for example, the discount price group if you're not interested in that. And that is basically here you're seeing the parent table, the child table, and then here's the link. Basically, it is linked on the retail group member and the rec ID in the retail group member line itself. So one other thing here is the insert defaults. So if you're kind of playing around with it and kind of got into a state that doesn't kind of work, you can actually go in there and delete everything. And then if you click this button, we basically insert the defaults as we're shipping it with the product. And then you can kind of start over again and try adding your new table, a new field to it, and kind of recover from that. And then to kind of show this in action, let's, I guess, just pick a product. And let's say we're changing the price on it. So when we save this, it will create a new pre-action. So the pre-actions are here. So the price is saved in inventory table module. We have got a record. It was updated. And then, as I said, there's some housekeeping things in terms of who's done it, when it happened, etc. And then also we're kind of showing if there's a link down action on this. So basically, if you change the price on the product, you don't need to send everything else that's related to the product. So there's no link down. So we're really just going to send this record out. So there are kind of then now two options. You could just click here and say create the action. This is kind of sort of manual step, kind of if you really want to follow along. Probably most likely you will have it here with the create actions, and then the same thing, set it up as a batch job. I'm just going to click OK, and we run it right now. And since this probably is the first time we're running it might take a little while since all the changes that we previously made are being processed as well. If we're then actually taking a look at the actions, so we're basically seeing the same thing here, obviously a whole lot more because of the link down and all the other related things that we have. It kind of blows it out. We've got a record of all the things that have been changed. The difference here is, as I mentioned, is the location filter. It actually tells you where it goes. This record goes to Seattle, this one to New York, this one to Boston, this to Philly, etc. And then here you got the actual table. And as I said, in most cases, you actually will see the record in there. So this is in the inventory table module. The rec ID is 2 with a sub key. The second key on that is the number 2. And then we can figure out which actual record out of this table we need to send to the Seattle store. And then the next thing obviously would be I go to my distribution schedule. And then since we changed the product, I'll take the 8-10-40 job. Either it would automatically be picked up because of the batch job, or I can run it directly, and then this price change would get sent out. So the next thing is then about the transaction service. Kind of already mentioned that it's synchronous access from PS to AX. I just listed some of the key functions that this enables. One of them obviously being the custom order, where we are creating sales orders, retrieving sales orders, updating them, etc. as needed during the whole process. Then you can also retrieve sales orders and kind of pay an invoice there. Then the customer validation, creation, etc. So we're checking the balance on the open balance on the customer. The inventory lookup, if you want to check from a POS terminal where the item is actually available. The cashier validation I mentioned yesterday during the worker scenario, where you could basically say, I want to first check in AX if this cashier is allowed to log into this store or not. And then also for creating or retrieving credit vouchers, gift cards, and then all the loyalty workflows that Jeff showed earlier today. They're all running through this transaction service. So it is a Windows service that is running under the context of a Windows user that has to also have access to AX. So this is the same principle as for Store Connect. The service has to run with privileges that it can actually read and write to the AX. By default, the port is set to 1239, so it listens on a port as well. As I already mentioned, that it requires a passphrase for the authentication. And then the transaction service profile that is associated with the POS, so the POS actually knows where to send this request. It's the server name, the IP address, and it just sends off this request. So here are the components, kind of very simple. The transaction service is, as I said, a Windows executable. It also uses PC.NET. So you need to install PC.NET on every box that the transaction service is running on. And then the POS initiates the transaction service call, which is then relayed through PC.NET into AX, executes whatever code is there, and then returns a result to POS. So the final thing we're going to look at is some of the monitoring in terms of, since this is kind of sort of distributed system, how do we actually keep track of what's going on, and how do we recover from errors? So there are a couple of key things for the Store Connect. So there is a log mode. So if there's some kind of error, you turn on the logging. By default, it will log it, write it into like a log file that is in the user directory for that user that it's running under. There's also then a checkbox that says write to the Windows event log. So it's kind of up to you what you think is easy to get to. If you've got some system monitoring tools that can actually upload the event log from the store, then you may want to log it into the event log and then actually check that in the headquarters versus going to the store and looking at the log file. Then the other option is the log levels. So multiple levels. I mean, probably the most important one is just on the error. So whenever an error occurs, we're kind of writing that error message into the that log file. But if you need additional information about what's really going on, you can pretty much kind of log it down to every function call that Store Connect makes, so you can kind of figure out what happens and what sequence things are being processed and where the errors occur. And then the other option is this keep package files. As I showed you earlier, both the request file and the actual data file are being stored into this work folder. By default, it's just kind of temporarily written in there, process deleted. So if you kind of need to figure out if there's something going wrong, like you get an error when you're trying to write it something, whatever, duplicate keys or some weird errors, you can actually keep those files. There's a tool that kind of can crack them open. And then you can actually look at what is the query that we're sending out, what is the result, and what is actually being sent from AX to the store, or actually from the store coming up in the case of a P job. So to kind of do this, there's this called package viewer. You kind of just point it to the file that you're interested in. There are two file types in this work folder. One is the I file, which is sort of the query file. The R file is the data file. That's the result that was the result of that query. And then you just click Convert, and it will basically turn it into an XML file that you can take a look at and see what's actually in there. In this scenario, it's basically we're sending the invent table down. You see whatever the data area ID, item ID, product ID, and rec ID that's being sent from AX to the store. So the other thing is, as I mentioned, we can upload the status messages from all those distributed message databases that StoreConnect is using into AX. So in AX 2009 R2, that feature was introduced. We just had a flat list. You kind of could scroll through and kind of figure out what the errors are, etc., and how they relate to each other. In AX 2012, we introduced this kind of visual representation of it. So it's kind of very handy, so because you can go to like a instance of when that job ran. So like, for example, you were downloading price changes last night. You want to see what happened. You just go there, look at the scheduler log, and say, this job ran last night at 11 o'clock. I want to see what happened. You just click on the button. It will show you this kind of visual representation of every hop this data package went through, and kind of show you, the result. In this scenario, if we start up here, you got like from the AOS, you already have an indicator with orange, something went wrong down the line. And then you kind of can step all the way down and saying, okay, at this point, here are the failures. Here's whatever these 3 stores that actually failed. And then you kind of can dig into and actually figure out what actually really happened. And then for transaction service, there's also a tracing option that is in the transaction service.ext.config file. We're basically using the .NET system diagnostics functionality, so whatever the configuration options, standard configuration options for .NET are, you can specify it. I kind of highlighted the 2 key things, like the switch value is, for example, error, or you could do some tracing there as well. And then the initialized data, that is basically where do we write it to. And then obviously you could specify which type of listener you have. If it's an XML format, you want to write it into Windows event log. Whatever is supported by .NET, you can actually specify here. And we're performing the logging based on that. OK, and now we kind of do a quick look at how this looks in action. So for the configuration of the upload, so there's this StoreConnect upload options. So you can either enable it, disable it. Oops, I'm sorry. All right, one more time then. We'll start out one more time, close this. So here's under the retail scheduler, you got the StoreConnect upload options. And you can set up different configuration based on different locations of what you want to retrieve and how often. So here the option, it's either enabled or disabled that you upload. Are you just interested in error message, or you just want to get everything so just you can trace and see when it happened and what happened out there? And then here's the interval. How frequently will StoreConnect actually upload those messages to AX? This upload option is then assigned to the StoreConnect. And then, as I said, you also need to configure the transaction service that you want. So actually, we're going to go back here to the upload options and say we want to get everything, because I think we haven't had any errors, so we probably wouldn't get anything just to look at. and then go back here into the Store Connect profile. What you need to do then if you make changes is basically send this configuration out to the Store Connect. I need to then kind of restart this so it actually takes effect. And then if we're going here to the inquiries, Retail Store Connect messages, we should actually see then all the status messages that are out there uploaded here. So there's some basic filter criteria. You can only show the errors. As I mentioned, we probably didn't have anything. You could then pick one message and say based on what other messages came back. So since each data transfer that's being sent out has a GUID attached to it, we can kind of associate all those messages, even if they go to 200 different locations. Based on that GUID, we can trace it back to saying this came from this one run of this job, and it fanned out to all those locations. All those locations probably send hundreds of status messages back, and based on that, we kind of can associate it here. So this is kind of still a kind of list view. If there are a few hundred in there, yeah, you can probably figure out if it's what's going on. But as I mentioned, you can use this here view message tree. Then you would actually get this visual representation of it. But probably what's more helpful is, as I mentioned, is if you actually go to the distribution schedule here, and we sent out the products earlier. So you have this actual scheduler log. This keeps kind of track every time this job is run. And then I could do the same thing and say, show me what actually happened with this run of this job. So in this scenario, it just went to New York. Everything was successful. And as I said, if there was an error somewhere down the line, you kind of could trace down based on all the hops that it went through. So for example, like here we got an AOS profile. So if for load balancing, you would have it split up over 5 store connects. So you would see already from here going out, it goes to 5 different hops. And then each hop then down, like this would be then at the store. How many store connects were there, how many databases were there, and you can kind of really trace down of what happened there. And then if we, no, that's not the one I wanted. If you go back to the Store Connect, I'm going to just take a quick view of some of the settings here as well. So the basics, we kind of talked about it, the port. There's then a telnet option that's available as well. So actually you can telnet into the instance, and you can get a quick sort of status of what's going on, like how many messages have been processed, what is still waiting there. It's not very informative, but it kind of sort of allows you to kind of get a quick heartbeat of that specific instance out there. Then the working directory, by default, it's sort of in the user directory for that, the application user data, I think it's officially called. So you can specify and point it anywhere where the user has write privileges to. Then the days messages exist is the status messages we just talked about. You don't want to probably keep them out there forever, so you can specify, like in this scenario, after 100 days we start deleting them. That's probably all you're interested in as well. And then the timer interval is kind of how frequently will Store Connect, the main thread, actually check if there's something to do. And the limit of job process, how many messages will it look at that are not processed with one pass-through of this execution loop. So there's just some kind of options to kind of can tweak it a little bit in terms of performance or however it works best in any given environment. And then you had a bunch of kind of other options here. The key things I kind of want to specify is here a timeout value. That's also like, you know, if one thread kind of gets stuck on something, it actually can get killed. So it's kind of the same thing. You kind of want to tune that in a way based on what makes sense. The maximum forwarding threads. So when Store Connect is actually sending out packages, data packages to the store, this is all done multi-threaded. So here you can specify how many threads or connections you want to use at any given time. And then there's some also some timeout values like the socket timeout, etc. The retry interval, if like there's an error that occurred, it will retry. You can specify how frequently it does, and also how many retries you want to do. So there could be, for example, you know, there's some error on the network. You want to retry it again, but for example, if the store disappears completely, it doesn't matter if you don't want it to retry forever. So you can really specify, you know, retry it 10 times. If that doesn't work, there's probably a serious error that I need to look at anyways. And then there's another option here in terms of the processors. So you could really basically say, I want to specifically allocate one processor or one core essentially to this Store Connect instance, or if you select all processors, the OS will basically do the switching for you. And then here's the logging functionality. We kind of talked about it. The same thing, you can specify where you want to have the log files being written to. So, and I just noticed that we don't have any, it didn't have the packages turned on, so I probably can't show you what the package view looks like. Since I guess we're kind of getting close in time. And then I guess a couple other things to kind of look at in terms of troubleshooting is you can go directly to the message database and kind of take a look at it. So there are two key tables that we're concerned about is the incoming messages. This is basically as soon as Store Connect receives a request, a record goes in here. When it actually processes it, either forwards the data package or inserts it in the destination, there will be a record in the outgoing messages. And the other two are basically for the monitoring. This is kind of the configuration that we set up in terms of uploading the configuration options, and this is then for the change tracking, the SQL change tracking that we, which message we actually had uploaded already. And if we just want to quickly look at what's really in here, you got the package number, so there would be then, if you keep the package files, there would be a corresponding file out there with this number on it, number 1. Tells you which service created this record. There's an information of the message ID. It was an N1000 job, the date, where it came from, the port it was using, date, time, then the actual location of where it is being stored, and then the status. So there's specific status. I think they're all in the technical reference, if I recall. But it says it's complete, waiting for being processed, an error has been forwarded, and things like that. There are, I think, 7 or 8 different status types that are being used. And then you kind of know what the status is. If an error occurred, there would be an error number. In the documentation, most of the errors are documented, and there's also some kind of explanation of what the error means, how you potentially can fix it. And then here it actually tells you how many records were processed. So you can get an idea of how many items were actually sent at that given time. And then the try count is if there is an error, it will tell you how many times it has tried it and where we're standing with the retry as well. And then the other thing here, the server message, if it's successful, it really also just says here's the number of records. But if there would be actually an error, there might be some error message that's in here as well, like part of an exception or something like that that is being written in here as well. And then, as I mentioned, the message GUID. That is kind of where we can track it. And the other thing that I actually haven't mentioned yet is the cancel by user. So for example, if you have a data package that is stuck in there because of an error, and you forgot to set the max retry count, you want to get it out of the queue. So you can either come in here, the database, and just change this flag to 1. Or also there's an option in AX when you actually look at the message. I guess we can go back in here. If I go to the retail store, connect messages. Let's say there's a package in there that I want to get rid of. I basically can click cancel here. This will send out a request to the Store Connect where this error message came from, and then this flips this flag, and then basically moves that request out of the queue and all the other ones process. So why this is important is because if there is an error for one job type, let's say for this example it's the N1010, if this one is blocked and you send it down a new job, it will not get processed until the previous one is processed. So you could basically couldn't recover from it unless you canceled this message.